So it looks like a caveman talking with itself, so that's the word. But you save a lot of tokens. And I mean, in that case, you probably save like 40-50%. You don't need to know like machine learning. You don't need to know like all these fancy math formulas and stuff. You usually like you can get a long way with just like software engineering and like, being creative.
The technology is not the most important part when we're recruiting people. It's the mindset of the people. So if you have the correct mindset to learn, to improve yourself and be willing to improve yourself
and adapt,
then you're a really good candidate.
So I'm here today with Oliver von Semkov and William Peltomäki from Playground. Can you please tell us a bit more about Playground, what you guys do?
Yeah, so I'm Oliver. I'm the CEO and co-founder of Playground Dev. It's a software and AI company here in Stockholm where we build AI solutions for companies and consulting within software engineering and applied AI, basically. And William is the CTO of the company, and we're a part of Playground Group as well, which is covering cloud engineering, data and AI and security.
Okay, so how did you both end up at Playground Dev? What were you doing before?
So me and Oliver studied together at a school here in Stockholm called Caveman, and we have since like worked a lot on projects together. I have done a lot of AI before, like all this AI hype, language models and stuff like that. So I've always had an interest for like AI and language models before, like the large part in language models. But yeah, we have worked on a lot of projects together. You started the company, Playground Dev, here in Stockholm. And I joined later.
Yeah, exactly. And for about 4 years ago, I started to, or 5 years ago, I started to work at Playground Tech, which is a cloud engineering company here in the Playground Group. So we created the company Playground Dev, which was focusing on software development. And because we had the cloud engineering part, we had project management, and we saw that software engineering was the last part, the last piece. And that was started 3 or 4 years ago, and 2 years ago, William started here. And since then, we have worked with AI, basically.
Yeah, I guess so. Like at previous companies I've been at, I was working a lot with like AI, but the old school AI. I guess you don't even call it AI, more machine learning and stuff like that. So I did like risk management projects, for example. So we created models that like rated the transactions, for example, and gave them a risk score and like if we should allow this transaction basically or not. Then AI became a thing, and Oliver called me basically and asked me if I wanted to join, as I had done a lot of AI before, and you had this plan of like starting to do AI within Playground Dev. So that's when I came in.
Exactly. So currently we are 8 people, and everyone and we are software engineers, but with AI focus.
So are those 8 people, they're AI engineers, or is it a mix of product people, or?
I guess there's like from the beginning, everyone is software engineers. And what we see at Playground is, or what we see in general is that AI engineers you don't need to know like machine learning. You don't need to know like all these fancy math formulas and stuff. You usually like you can get a long way with just like software engineering and like being creative.
Yeah.
So what we have done is basically we have been starting from like, I think 8 engineers that we have like trained to become AI engineers pretty much. So we do that through like continuous learning sessions. We apply this at real companies, and I guess that's the main focus for like, so I would say now they are AI engineers. Most of the people are AI engineers, but started off as software engineers.
Cool. Yeah, I think that's very interesting how you say that you don't necessarily need like the AI skills to work in AI as a software engineer. Because right now, the AI engineer role or working in AI is like one of the hottest fields right now, especially if you're a software developer. A lot of people want to kind of break into this. So with that being said, when it comes to like building AI teams, what makes, a very good engineer someone that you can, convert to or turn them into an AI engineer. So what do you really look for?
I would say I think creativity is a very strong factor. I mean, there is a lot of. I mean, you could look for has this developer worked with these kinds of frameworks, for example, but first of all, those frameworks some of those aren't even a thing. Like some months later, there's a very fast space to work in, and a lot of changes in frameworks and technologies. But I would say that the common factor is that need to have this kind of R&D thing. Like you need to be creative. You need to have a drive to test things and validate things. And I mean, and you can see this as well. I mean, there is if you go back and look at what's the largest shift in the AI space currently, I would say agentic AI is one of them, for example. And
sure.
I mean, that is one thing that has made AI go from it's pretty good to it's very good. And that's not a model change. That's more of developers being creative, changing the flow of where the information goes, transforming it, setting goals, having AI plan for its next steps and stuff like that. And I guess that's what we are looking for in engineers. I mean, the drive to try this stuff out. I mean, it's all about creativity in my eyes.
And and just to mention, when we're talking with when we're recruiting new people to the team, we focus more of that you have been a software engineer and that you have been creative on the side. You have tried the new products, all the new tools and frameworks that have appeared, and to not just work in one type of project, just to try the new stuff, try the image APIs, for example, or try some agentic flows or deep agents with LangChain that has come, for example. So if you are creative and trying this new stuff in your products or some vibe coded tool just for fun during a weekend, that is super good. And because and if you have the software engineering part from, for example, an enterprise environment, that is one big part of our customer base, then if you have the agentic part in mind as well, then we really can combine this to create good stuff for our customers.
Yeah, I guess that's one thing as well. How it's very easy to miss. These are, I mean, AI workflows and AI solutions are basically normal software engineering. It could be a microservice that processes data, for example, and it's very easy to miss all the essential parts, like metrics, scalability and stuff like that. And I mean, that's why we see that you don't have to be a ML engineer or data scientist. You need to know all of this, have worked within maybe some enterprise environment, for example, and applied these kinds of scalability techniques or metrics, like visualization of data and stuff like that, but for the old school way of doing it, or how you want to call it, but for this new AI wave as well.
Right.
And yeah, exactly as you mentioned before we started this podcast, that to have a full ML engineer in a team where you need an AI engineer, then you miss a lot. You miss the part where the software development, the full image of the architecture, and for example, how queues work, how
basic data structure stuff.
Yeah, exactly. Which can be really powerful when you are using AI tools and combining it together. And then you lose big part of it. Many ML engineers have that, of course. But it's not just writing Python scripts. It's a lot more than that.
Yeah, exactly. And in my experience of recruiting and hiring AI engineers, we get a lot of candidates that are, the ML engineer role, and they have a quite standardized profile. They maybe have a PhD in machine learning. Sounds very impressive, and they've done a lot of cool, projects and papers. They maybe even worked as ML engineers before at big companies. But it seems like a lot of that profile is just very much focused on the data side of things and not the applied software engineering. And bit of a miss there, and that's why I kind of agree with what you're saying. That it's kind of easier to convert a software engineer who knows how to code, who knows data structures, and they just teach them AI. Especially if you're just dealing with GenAI, because GenAI is so new. Like, we can't even expect people to have experience with it. Yeah, so let's just train them ourselves. But given what you said that you kind of look for in engineers, how do you find these traits, like in the recruitment process? Like, let's say you look at the resume, or you had the interview, the behavioral or the code test, etc. You also mentioned that you look for like an interest in projects. So could you also mention like the impact of open source contributions? Could you go through that selection process a little bit?
Yeah, I mean, and it's very hard to like. I mean, you don't get this picture from just a resume, for example. I mean, you have to meet a lot of people. You need to. I would say, I mean, as I said before, working on projects, like having hobby projects and stuff like that, is a very, like, we value that very much, and it's. If the developer can showcase something that they have built and explain it, that's one thing that we look for. Otherwise,
could you give because a lot of people do hobby projects that are like kind of copy pasted or lovables. So it's easy to just fill your resume with projects. But is there like a certain portfolio project that a certain type that really makes you stand out and be like, wow, this is a cool candidate?
Yeah, I mean, and it has become a lot harder now when you can generate a lot of code. I mean, there is, I mean, before all this, like generating code using AI, it was much simpler to say, like, I mean, even if you had copy pasted code and made it to something yourself, that's still an impressive thing to do. I mean, nowadays you can just give it to an AI, ask it to like do some changes, and you don't need to know like what's happening. But I would say, so it's much harder than it was before. But I would say, like, we have seen some candidates that has worked with, for example, let's say a new chunking strategy for RAG setups, for example. And I know that, I mean, AI are very good at building stuff that already exists. So if you build something that doesn't exist, that shows that you are like good at prompting the AI, for example, because the AI always tries to do shortcuts to, like, one good example is that if you try to ask AI to use the GPT-5 model, for example, that's very new, then it always goes back to GPT-4o, for example, and says that, I changed it to GPT-4o because 5 doesn't exist. And it's same with, say, the whole, like when you work on AI systems, I mean, there isn't a lot of training data, like code-wise, for AI workflows and stuff. I mean, the normal way is maybe NLP for language, like when you want to understand language, and maybe just simple if statements. And you see that a lot when working with like hobby projects, that there is parts of the code that uses old school techniques, for example. And that's something that we look for. I mean, if someone has written, for example, a new way of chunking, like for a RAG setup, I mean, that's something that we value because it's something new. I mean, we don't value maybe just a normal app, for example.
Like a clone.
Exactly. If they have, I mean, there is, I mean, portfolios and like showcasing what you have built is like, I mean, you can see that a lot. I mean, people that has a website with, say, 100 of projects that you can see straight up. That's
it loses value.
It doesn't have any value anymore.
Yeah, JavaScript calculator. Wow, so sick.
Yeah, exactly.
But for example, if you have a vibe-coded application, but you can explain everything what you have done, that's a pretty fun test as well, because I can't explain my vibe-coded application that I do on the weekends neither. So, but if you have worked on something and want to explain that you have done this and this is like a real deal, and you can explain what this is, what it is, why it does like that, then we really can value you for that. So, and for example, the other part, just to mention that the technology is not the most important part when we're recruiting people. It's the mindset of the people, because it's harder to change the mindset it's a lot easier to increase the competence within an area. So if you have the correct mindset to learn, to improve yourself all the time, and be willing to improve yourself
And
adapt, then you're a really good candidate.
Going on what you said, Oliver, about being able to explain your vibe coded apps, I also think, in my experience from when I was looking for a job, and also now that I'm screening people for AI engineer roles, is I think it's very important to have projects where they could be vibe coded, and like honestly, in my opinion, you don't really exactly need to know the ins and outs of all the code that was written. But if they have like some real business value, I think that's super cool. Like even if it doesn't generate any money, but like if you can concisely explain like here's a problem, here's a solution, like maybe I'm not the person to solve it, but here's like how you can solve it with technology. I think that's super cool. And that's something I've used a lot when I was looking for a job, because right now people are just kind of spraying and praying and like doing clones of everything. But I think we see a shift now in the software engineer role where it's like, because the coding is doing so much heavy lifting, that like people need to be more product minded, need to understand business more, and like really understand like how can I make or save money. You know, it's not so much like how can I write the cleanest architecture possible. Like nobody really cares anymore, but at least in my world.
Yeah, but it's still important to know, like for example, what you have done.
Yeah.
And because there are risks as well. If the application, if you haven't seen the code, for example, and then everything breaks, you don't know why, it's harder to debug, you lose time, etc. So, but that's exactly what we're looking for, as you mentioned, that you are creative, you're business-minded, product-minded. It's super important because it is shifting there towards the product mindset from the algorithm mindset, or looking on the code line by line, but to understand what you have done is super important.
Yeah. And I mean, like developers are in some ways becoming more of like project owners, or they are basically we are prompting the developer in this case to do the work for us. So I guess setting those like rules for the agent, how it's going to like output code, what we want outputted, and like doing all of that work is much more important now than it was before.
Right.
And that's, and that's something you can see in code as well. I mean, if you look at a vibe coded project, you can usually see, if there is a lot of like spaghetti code, for example, then you see that the setup isn't very good. You maybe have prompted it with bad context, for example. And so you can usually see on projects that less experienced vibe coders have made, because there is bad structure. There is maybe, they maybe haven't put a system prompt for the agent to follow some kinds of guidelines and stuff like that. So that's also something that we look for when we see like hobby projects and stuff like that.
Yeah, that makes sense. Great. And when it comes to like, so, right now, especially in Stockholm, it feels like we're in the AI gold rush where everyone's trying to build AI projects. A lot of people are trying to recruit AI engineers and build engineering teams. So since you have done that at Playground successfully, could you talk a bit about like what goes into building a successful AI team, for AI projects? What are some challenges you've faced?
Yeah, one of the largest challenges is that the technology shifts so fast. Everything that is new now will be obsolete within 3 months or 6 months. And the new technology, you have to be up to date all the time. You can't just sit back and relax. And even for an AI delivery that we have done for a client 1 year ago might be, would need an update now to follow the latest and greatest ways of working. And that's the biggest challenge here, I guess, right now to follow up the new ways of working, new ways of following the new type of workflows. So, for example, agents and agentic workflows, like 2 years ago, that was hard-coded theory parts on the paper, but 1 year ago it was stuff that we worked on maybe, but now it's a super simple framework that you can use. And the same with RAG and everything around that, and then embeddings and such.
Yeah, and then I would also like to add the human layer in all of this. Building, you need people that are adaptable. Because when we work for clients, for example, we see a lot that, I mean, everyone needs to like want to try it out because there is a lot of friction when it comes to AI. Some like senior engineers that doesn't trust AI, for example, or people that just doesn't know what AI can do if you do it correctly. And I mean, this is all from like management to developers. And that's something that we do when we work. I mean, we do different kinds of work with clients, and sometimes we deliver products like on a plate that they can use like tomorrow, for example. But we also do work with the client and work within teams, and that's more because people see that AI knowledge is something that they need on the company level. It's not something that you outsource and just get a ready-to-use product. And so we work with the teams that, I mean, they have maybe, say, 3 other developers that they want to invest time in so they can learn AI, for example. And I mean, then you need people that wants to try it out, wants to see what you can do with it.
Right.
And exactly. And there's a challenge as well because on the one hand, the clients want AI, just sprinkle the AI on their product and everything works. And they don't know that this doesn't work, or they think that everything works with AI and everything will be super good and everything around that. And then we have the other part of the coin, which is the skepticism part. And that's the people that don't trust this. So it's really hard to work with this new ways of working because we have two big challenges.
Yeah.
But there are like, if we can prove for the client, for the skepticism part, that it is possible to do this kind of stuff, and for the customer to show what is possible with AI, that not everything, but you can't solve everything, but you can do really cool stuff.
And so, what is that skepticism usually rooted in? Is it like due to the non-deterministic nature of LLMs, or is it like they're scared of giving away their data? Why are some companies like skeptical towards implementing AI projects?
I would say both.
Yeah.
The data is super important, and people are scared where the data goes. Even though if you have your own hosted AI solution in Bedrock or Azure AI, for example, you share the data in other services, but not for the AI, and that's pretty like black box scary. So that's like one part, and part. What was that?
Wait, so you got me confused.
Sorry.
Yeah, so one is the company they don't want to outsource the data. The other one is the non-deterministic nature of LLMs.
That AI doesn't work.
Yeah, exactly.
Yeah, exactly.
It's 100% accurate.
Yeah, and they try it. They put a prompt and or they use Cloud Code, for example, and then it proves it doesn't work and that you can't build something better than that.
Yeah.
Even though it is possible, depending how you work with the context, with the agents, and everything around that. And it's hard to prove that you can build better stuff that are out there. But for example, Cloud Code it's meant to be optimal, to save tokens, to be fast on responses. But if you switch that part to have a slow agent and it costs a lot, then you can get another type of value from the results.
Yeah, and I guess it like everything roots in lack of knowledge, I would say, because as your Cloud Code example, I mean, if you ask Cloud Code to like explain this whole code base, which is a large monolith that's lived for 20 years, for example, it might do an okay job, but it will miss a lot of stuff. I guess that's not a very good picture because you can use like sub agents. You can set it up in a better way, you will get better results. And I guess a lot of people doesn't know what you can do with AI, and that's one thing and then there's also like this whole part of like senior developers that knows that they're very confident in what they are doing is always correct, and they have done this for 20-30 years, and they feel like AI won't take my job because it doesn't do this and it doesn't do this.
Yeah.
And we've heard someone that said that they won't use agents because they just output like shitty code all the time. And you want to say like shit in, shit out, basically. But you can't say it to their face.
But yeah, and it's the same with like large amount of documents. If you talk with, if you put too much data in just ChatGPT, you get bad results. It hallucinates, etc. Or if you have a RAG solution, but you have not, and you don't get the same result as you want, but you maybe don't know that you can use agentic RAG, for example, to get better results in some kind of ways, and like it's the competence, like, and you have seen one ways of working, or you have prompted an AI to build something, and it didn't build it as you want, and it gave you a system prompt auto-generated, and everything's like really bad. Then you get a bad experience, and then you have a bad experience for everything within AI.
Right.
Yeah.
Yes, on the topic of like optimizing is not providing a shit ton of context to an LLM, because we know like usually that reduces the accuracy and the quality of results. I like to think of it as like in traditional software engineering, there's like the CAP theorem, right? Which is, what is it, partition tolerance? What's the C for? CA? I'm drawing a blank here. I don't know. We'll put it in somewhere. But it's basically a trifecta of three things. You can never have all three. You usually have to sacrifice one for the other two. I've kind of realized as an AI engineer, it's like there exists sort of the same thing in AI engineering. This is all my theorem, of course, where it's like you have to strike a balance usually between cost and when it comes to like chatbot applications or stuff where like latency is very important, and latency comes in, and then the accuracy of the results, because usually if you're trying to get low latency, if you're trying to get high results, you usually need to use a bigger, better model, which usually is a lot slower and a lot costlier. So I think you always have to strike a balance between all three. Is that something you noticed as well?
Yeah, for sure. I mean, there is, as the example that you mentioned, I mean, you can use Claude Code for like asking it to give some input about how a service works, for example. But if you want this deep dive into how it works and validated results and all of like that kind of output, then you would need an agent that goes through maybe one file at a time, looks at it, like validates its output, and I mean that whole flow. And I mean, it is all like as you say, it's about like balancing what based on what the needs are. You need to balance, cost, latency. I mean, there is both like larger models for larger tasks or like better quality tasks, or more like agentic steps for like splitting out, doing smaller chunks of work. But yeah, for sure. I mean, there is we see that all the time, and sometimes people. I mean, that's also one thing. People expect AI to solve like everything, and if you, I mean, we have had some clients that thinks that this goes too slow, for example, but we need to do it that way because that's also the requirement. We need to validate everything, so of course it will be slower.
Could you tell us about any of the projects where you kind of like need to manage or reduce latency or cost in an agentic or LLM application?
In the chatbot application where we use the camera to make a screenshot of a picture of some recipes and talk with the recipes, then we have a lot of processes in the background, and with that it can take some time, and we have to validate all the products in the picture and validate against the recipes that we are talking with, etc. And in that kind of case, it can be slower response time, but if you do it if you add less validation, then you get faster results, but risk for a worse response, for example. So that's like one case, I guess. I don't know if you have an example, but the reverse part is when we're working with a lot of data and a huge amount of context.
Right.
But then it doesn't matter if it takes time, because when we are working with a lot of context, for example, then it can take time. We are pre-processing a lot of data and preparing it to talk with the data thereafter. So the pre-processing part, it can take time. It doesn't matter if it takes 1 second or 2 hours to process this amount of data, as long as you have it prepared for another agent that is fast to retrieve the data. So like that's like a reversed thinking, that it doesn't matter if it takes longer time for a cron job, for example.
Yeah, something I want to do that I want to try out, but I just haven't had enough time. Mainly on the optimization part, trying to find a balance between like cost, latency, accuracy. Usually, a lot of startups are locked into like GPT and the big models, mainly because Azure has the Star program where you get locked in using Azure, and then I think they only have access to OpenAI. So a lot of startups are limited there as they have their credits. What I want to do is like experiment a bit with open source models to see, there's a lot of things you can do. You can find like a smaller model that's maybe more specialized for one use case, or you can even fine tune a smaller model with your own data, etc. Do you have an experience working with open source models, fine tuning, or do you have any experimentation with that?
Yeah, and it's a very valid point. Like you get locked into, the big ones, OpenAI, Anthropic, for example, and it is of course a risk, and also for the point on if you value your personal data maybe within the company and stuff like that, you might want to use a smaller model for some kind of processing. And we have done projects where we give small and specific tasks to smaller models, and that's also one thing that you see with recent development. The costs of larger models are increasing, for example, and you also lose control over your AI when you outsource it to these big companies.
Yeah.
So there is, and at the same time you can see with, for example, DeepSeek was a long time ago in the AI space, but you can see that reasoning, for example, improves output by a lot, and you can use smaller models, run it locally, and get pretty good results. And as you mentioned, fine tuning on specific tasks, and as long as I see that as kind of the next wave within AI, that you can already see it with sub agents, for example.
Yeah.
You try to, you don't, before when you used Cursor, you asked it towards the whole code base, make these changes. And it looked, did some embedding search, got some files, did the change, and everything in one. But you see that you get much better results if you break it down, give it very specific tasks, and I feel like that's a very good first step to breaking it out to smaller models as well, or local models in that case. And we see the
what was the name of the part for recurse, for example? Do you remember? The tiny.
Which one?
For tiny models, or
the Samsung model.
Yeah, exactly.
So I can't remember the name, but Samsung did this experiment where they used a very tiny model. I can't remember how many parameters, but it was
I thought it was millions.
Something like that.
Yeah.
And got better results on solving Sudoku puzzles than large models did, because it was.
Was it trained on Sudoku solving?
Instead of I don't know if it was trained on Sudoku solving specifically, but I know that what it did was a recursive way of solving it. So it proposed a solution, then it refined the solution over and over. Okay. So it used more iterations, but it was a tinier model. It went faster and iterated on the problem, and that's something that they could solve Sudoku puzzles better than large models using just creative data flows, pretty much. And so that's why I think even if you use no matter if you still use Anthropic or OpenAI or local models, that seems like a very natural next step.
Yeah.
So and I mean also based on costs going up, for example. I mean there is, you see how they increase subscriptions. You can see how token usage for the APIs are going up, and I mean people need to start optimizing and start to think about like what are we spending these tokens. Like is it unnecessary that we spend this amount of tokens?
Yeah.
And start to think about like what context do we provide it with, how do we solve it, like what do we ask the AI to do, and I mean if you can get the same results with smaller models or local models, then why wouldn't you use it?
Exactly.
So
Yeah, I think theoretically, because like I said, I haven't done this in practice a lot. Then having a smaller, fine-tuned, or specialized model for a certain task seems to be better in all cases: accuracy, speed, pricing. So I think about this a lot actually, because I think about let's say the big three: ChatGPT, Gemini, Claude. You can throw in Grok in there as well. Sure. It's like they keep improving their large models and they keep getting better and better, but it's like marginally. It's like in like 5 years from now, how are they really going to improve? Because these are big tech companies. They need some special sauce all the time.
yeah,
Something I've thought about is like, you can't see ChatGPT doing a little bit of this now with, was it ChatGPT 5.1 Insta maybe, where it's like it will look at your query and be like, is this a smart like do I need to be dumb for this or smart for this? And like I'll route it to an appropriate model.
yeah,
So what I've been thinking is like the future of like, let's say ChatGPT could be that they just have a bunch of models that are trained like smaller but trained for a very specific purpose, like maybe even like hundreds or millions of
for sure.
small, and then it'll take the query and just route it to the be like, oh, this question is about real estate or e-commerce, okay, and then it goes to that one. It's super fast and it does the job very well. So that's why I've been wanting to like experiment with this so much, but just don't have enough time.
And they probably have like key value on the hello part.
Yeah.
So, for example, when you say hi to the ChatGPT, they probably don't use a model for that. They have like hard-coded response. Probably it would save millions at least. So, yeah. So, like the token optimization is a big part, and we see that this will probably a big focus on the coming years, like next year and the year thereafter. Like the token optimization will be like a crucial part, because if you save the costs of of the tokens, you can save a lot by doing smart things. Then you can really increase the value of the agent. And the token optimization part, you have worked on Caveman Compression, for example. I don't know if you have seen that.
Yeah, I saw it, but please, you can tell us about that. It's super cool.
So I guess it it began with, I mean, with these kinds of thoughts. I mean, why, like, what are we doing that is unnecessary? And I mean, I experimented with like different ways of saving tokens. I tried, for example, I mean, which is a very good way as well, but like using large models for planning and small models for implementation, for example, because like the planning and looking around in the code, if it's a coding agent, is usually the extensive part, and then it can provide a very like a step-by-step guide for the smaller model to like do the actual implementation. The large model doesn't have to do that. But then I started to think like, okay, so we do like reasoning in the large model and we do implementation in the like smaller one, but how can we push this even further? So I started experimenting with like this, I call it Caveman Compression, because it's we try to remove as much words from the prompts and reasoning and still have it like perform good.
Yeah.
So it looks like a caveman talking with itself. So that's where
But
the
not
name came.
stop words.
It's not like as easy as removing stop words as NLP, the NLP sphere calls it. But I mean, remove words that are easily predictable by the agent. So let's say if you have, what's a good example?
My house is on fire. It's not so good. So please call
911.
911.
Yeah. So instead of that, we can use house on fire, call 911.
Yeah.
So, and it's basically the same, like you get the same
Semantic understanding.
Yeah,
exactly. But you save a lot of tokens. And I mean, in that case, you probably say like 40-50%.
And how do you figure out what words to remove?
I've tried the different approaches to this. I've tried the first one just to try out the concept was using a small language model that looks at this prompt and tries to just like make it smaller. But that also opens up for stuff like hallucinations. It might miss something that is crucial, and we saw that in benchmarks as well. That it's like it usually misses some parts, and you get like okay results from it.
Yeah.
So I started. I tried out another approach where we use a MLM, a masked language model, where we mask a word, so the model doesn't know which word this is, and we try to predict it. So if this word is very easily predictable, then we might remove it. Depending on like other rules as well, because I mean, let's say climate change, you have climate and then a masked word is bad. I mean, change is very predictable.
Yeah.
But if you remove change and just have climate is bad, I mean, that's removing like a lot of. So we have some rules on top of that, like what's the word, like I can't remember the word, but there is a lot of like, I mean, NLP libraries for identifying words. So we use NLP for like tagging words, saying that you can't remove these kinds of words, but all the others are free to remove if they are predictable. And we got very good results from that. It's like the benchmarks are showing that we can remove up to, I think, 40% in like a lot of. We have a large data set with like where we basically have like a data set that is like text that we use for context, and we have a bunch of questions. So it's using RAG pretty much to just see how many questions can we answer if we remove X amount of words. So in this case, I think we achieved 40% smaller prompts with 98% quality.
Wow.
Where like the median value is still 100%, because I think it was like 80% still gets 100% questions correct. So which shows that we are using a bunch of unnecessary words from prompting models.
Yeah.
If you can save 40%, I mean, in a hobby project that doesn't make I mean, it might not be that much of savings, but if you look at like a company that spends millions a month on tokens, and you can cut that with 40%, I mean,
it's a lot of savings.
Yeah, exactly.
Cool.
So, yeah.
White paper is coming soon.
Yeah, I was going to ask, is
William.
this internal knowledge, or will other people be able to learn about this Caveman compression? Because this is super interesting.
Yeah, I have a GitHub repository up right now. I'm waiting for approval for like a white paper that's going to be published as well.
Cool.
So hopefully that will be published soon as well.
Awesome. We're looking forward to reading that when it comes out.
Yeah.
And I'll put up the GitHub in the description so people can look at it. Nice. So I think that, we're ending 2025 right now, getting to 2026 and onwards. I think we're going to see a lot more of these creative strategies to, how we interact with LLMs and, AI, like beyond just like choosing different models, like these different creative techniques. I want to ask you guys, like, how do you see, the future of AI engineering developing, 2026 onwards? If you have any thoughts about that.
Yeah, I can start. It's like one big shift we will see, as we can see it right now at least, that more of the software engineers in the teams will have the AI knowledge. They will be able to build their own agents. They will understand that we can solve this with agents, not just how to use AI to build stuff through Cursor or Copilot, etc. But they will also see the potential, but also test this, because agents and AI, it's a tool. It's a developer tool.
Yeah.
A part of it at least. So you can use this and see, for example, if you have error logs and you want to have some semantic understanding of the error logs and get the information from that like instant from an agent without looking in the log history in Grafana, for example, then you as a developer will be able to implement that yourself without having to talk with some AI teams that do it for you. And we talked about this earlier today, that AI teams won't be like the same part of the company. It will be more divided on the engineers as well, the AI competency.
Right.
That's one part. Yeah.
Yeah, and also like for cost, the cost perspective of this whole, as I mentioned, the prices are going up, and I think like as well. I mean, I can't even remember when did ChatGPT release? Was it 3 years ago?
Was it
became popular?
2022? No, 23.
22, 23, I'd say.
Yeah. So I guess when it began, I mean, it was more of like, yeah, this is a cool thing. We don't know how to use it, but some people are trying out some stuff with it. Then we got into this like experimenting phase where a lot of companies did proof of concepts. They tried out a lot of stuff, which like a lot of stuff that worked, a lot of stuff that didn't work at all. But it has been like this kind of like Wild West when it comes to like what do we spend. There isn't a clear budget on like how much can we spend on AI, and we see that I mean this will become, I mean, as this is becoming like a clear way of working in many cases, and like slowly becoming a part of a lot of products. We see that, I mean, budgeting will be a lot like clear. There will be like AI budgets in a lot of companies, and also like I mean something that comes with that is optimization, as we talked about. I mean, I guess it's like pretty smart to just throw a lot of money into getting like knowledge and having people experimenting with stuff, but I guess the next step is to do it in a reasonable way, and like having good structure around how to build AI, like the budget, I mean, doing it as we work with normal software development, but I mean, like we don't. I think we won't see it as this experimental kind of work anymore. It will slowly become like part of the normal software engineering routine.
Yeah, and also as you say, the cost. For example, the average developer maybe spends like on the private side like $20 per month for Cursor or their Copilot they work with. But when you work with these kind of tools, the spending is going more maybe $200. I think we have average $200 per employee in our team, and for agentic tools that we work with.
Yeah.
And
90% as Cursor, maybe.
Yeah, exactly. Cursor, Cloud Code, for example.
Yeah.
But and Codex. But for all of the AI tools that we use, I think we're up to $300 maybe.
Yeah.
Like if we add some more, but
And that's on top of all the other stuff you need for software developers.
yeah, exactly. And for example, the larger enterprise teams that are starting to implement this kind of stuff, they have in mind that we have talked to at least that 200 crowns, $20 per month is like the standard. $30 per month is the standard per developer.
Yeah.
And they will have their eyebrows raised when they see $300 bills per employee per developer. And we can see that shift is coming. Even though the models don't have it right now, the better model will come, they will tweak it, and you will have to pay this.
Yeah.
And as a developer myself, I get the the drug feeling when they turn it off and I need to refill my cap for having the cursor back again.
Yeah.
So you get addicted to using this kind of tools, and so we can see the costs are. They will probably spike up, and the budget will spike up for the enterprise companies or all the companies that are using this. And previously, we have seen that the budget has been on the POC part, the proof of concept, to create this kind of stuff. But now the budget will be also on the usage, the inference for the models that they are using, and not just for the development, but also for the products. So as William has been working with the optimization part, we really see the value of that, and we think that this will be a big part of 2026 and further.
Right. What do you think of something I've noticed recently is Python has for the longest time been like the ML and GenAI language, but I'm seeing a big shift into TypeScript being used in AI. Seeing big frameworks like LangChain, LangGraph being written in TypeScript, and I just heard a lot more AI companies that are like, yeah, we're just gonna build everything in TypeScript because we have to use TypeScript for front end anyways. It's easier. What do you think about that? Is Python going to be replaced? Is TypeScript, could it be a better like language for AI?
I mean, like my view of this is I'm a Java developer in from the beginning. So
Okay.
I worked with like these kinds of. I mean, Java is very verbose. It's very hard to. It takes long time to get something to work, and you need to. I mean, in a good way. I mean, that's why like a lot of enterprises work with like Java, for example.
Yeah.
It's a very like non-sexy language.
Yeah.
But I mean, you get very stable systems and easy to maintain and know what's happening. So, but when I worked with like pre-AI, when I worked with hobby projects, normal like usually hobby projects are also like do it in Python because it's fast to get something running and try it out. Me personally went to TypeScript before AI because I think that it also provides this kind of it's very easy to get something up and running, but you also get the type safety and all of those like necessary stuff, but kind of boring stuff as well. So I mean, me personally see it as a good thing because I have gotten used to TypeScript. I've always been like a hater as all of the tech people of like JavaScript in general before. But I don't know. I feel like it's, and as you mentioned as well, like having, I mean, React being written in TypeScript, for example, you write the backend in TypeScript and like have some kind of, I mean, when we are working with agentic coding tools, for example, language choices becomes less important. I mean, nowadays, I mean, when we recruit people, for example, I mean, let's say they have worked with Java, but we want to recruit them for a JavaScript like TypeScript role, for example. Then we don't see that as like as large problem anymore because they will use AI and they know the basics of how like coding works. So I don't know, like.
No, exactly. And if you look like 2-3 years ahead, then the languages might be like the coding languages might be language agnostic. So because as long as you understand the software development, you understand the architecture and how everything sticks together and the best practices of the language you will work with. And if you have a good agent that you are talking to, it will probably not be a big problem to go from Python to TypeScript or from TypeScript to Python, for example. Me myself, I haven't worked with Python so much. I have done some project a couple of years ago. Now I'm building a solution for in Strands agents, for example, and that is like 100% Python, and I don't feel any issues with that. And it comes pretty natural when you're working with AI tools to generate code, even though you have to have your eyes open because you have to understand what's going on. But yeah, so if you look a couple of years ahead, then it will be interesting to see what will happen with the coding languages.
Yeah, if we'll even need one in the first place.
Yeah, exactly.
I'm a diehard Python programmer, so not a huge fan about the shift to TypeScript. I had to use that at work. So I did learn JavaScript before when I was just a full-stack developer, and then since learning TypeScript, I must say I do love it a lot more than JavaScript, and I'm hating how much I'm starting to like it. Also, I think when it comes to like Gen AI and AI engineering, it's like seems like type safety is ever more important. For whereas before, like I never used to give a shit about types. I was like, a variable is a variable. Like fuck this shit. But since using it, it's like wow, it really makes you so much more productive, and like you catch errors way quicker. It's easier to understand someone else's code. So just having that built into TypeScript, I think is a big leg up from Python. So yeah, but yeah, definitely interesting to see what's going to happen in a couple of years. You know,
Yeah.
languages in general.
And all the models that are trained on the open source data, which
Yeah.
is more and more JavaScript from the front end and the back end and everything that is produced, then the models will be better and better, or better, not better maybe, but more trained with that kind of data.
Yeah.
So most of the, for example, lovable products are probably JavaScript and TypeScript, and everything that is pushed will be be available to make the models more TypeScript-ish.
Which is also like scary thing, because I mean, as I mentioned before, if you prompt like your coding agent to add GPT-5, for example, and it doesn't do that because it doesn't know it exists because of its training data. I mean, it's the same with framework choices. And say, I mean, if you ask agent to create a, let's say, web app for looking at parking spaces or whatever, like you create a web app in general, then it will probably create it with React, Tailwind, and all of those frameworks, which is because of it's training data. A lot of open source projects are written in that way. And I see potential like security issues in the future, because it will use maybe versions that are not supported anymore because the training data had it. It will have a hard time to adapting to new technologies, because that's also one thing. I mean, I want to see the output language of agents be like some low-level language, because now when it doesn't matter as much of, like, you don't need to know the language as much as you did before, then why not use like Rust or C or whatever? I mean, have it quicker and like more stable, and instead of these high-level languages that are essentially only a way to make it simpler for humans to understand.
Yeah.
But if the agents are doing the coding, then why not like have them write
Binary.
Exactly.
Yeah, definitely. So I have one more question, if you're both up for it.
Yeah.
I know we've talked for quite some time now. But so Playground works a lot with enterprise customers and the cloud, right? So I think that's very interesting, because that's something that I've not had exposure to, and I think a lot of people have not. People work in startups that I don't think sell to enterprise. If you just talk a bit more about how it is applying AI in enterprise and cloud environments. Very general question, I know, but I'd be very interested to hear a bit more about that. And also like the challenges unique to the cloud and enterprise clients.
Yeah, it's as you say, Playground works a lot with cloud engineering, cloud data, AI, security, all that part. We have worked with AWS, Azure, and GCP, mostly with AWS. And when we're working with our clients in the cloud, then we use the services mostly that are provided by the cloud service. And for example, in AWS, we use Bedrock, strands, agents, for example, with the Python example, agent core to host everything and have that kind of framework. And if we have a client in Azure, then we use their own tools and the model providers that are provided by the cloud. And that's one important part also when we are doing, for example, the context gathering part from our services. Then it's really important for our clients that they want it self-hosted. They want the data on their end, and the models should be used by their own services. Everything should be stored in their own service. So, for example, in S3 or their own databases that they provide from their own environment. And that's one part of it.
Yeah, and I mean, we also have like a much higher requirements on, say, scalability. We have security and all of those parts as well. I mean, it's as we mentioned before, it's easy to miss those kinds of points when working with. I mean, it is in a lot of places, AI is just experiments that they like try out on the company. But when we deliver products, it's we want to provide something that they can run in production with like thousands or millions of customers, and then it becomes very important to think about token spending, for example, or if we work with a client-facing product that users will actually interact with, then prompt injection or DDoSing in form of in terms of sending a lot of prompts to it and draining the company account
Right.
and tokens.
Analytics and monitoring, and for example, analytics and monitoring using Langsmith to have a good understanding of the prompt of everything, how the agent got the results, for example, and you can follow up everything, and that's a big part of the new EU AI Act that is coming, for example. That's that you have to be able to trace everything, how the agent got that result. So, for example, if you use a tool that gives you advice for something, then you need to trace back how it got that result. And that's and Langsmith is really good on that, for example, and the other tools as well. So it's really important with everything such as security, guardrails, traceability, scalability, and knowledge sharing as well, which is super important, because when we work with our clients, they want to get the knowledge about AI, how to work with this later on without being dependent of us. So one big part is knowledge sharing as well, which is something that we're doing a lot. Yeah.
Great. Awesome. Well, that's all the questions I have. So thank you so much for that. Do you have anything to add before I start wrapping up?
Yeah, I don't know. Feels pretty good. It's super fun to make this kind of podcast as well.
Yeah.
And it would be nice to hear about what you're doing as well on the Pict, but maybe we can take that on the next time.
Yeah, next time for sure.
Yeah.
I just want to say it's very nice that we sit down and talk about this. I really value your transparency because, as we all know, there's so much happening in Stockholm right now. We're in the world, but in Stockholm, especially in AI, things are happening so quickly. So the fact that you were willing to sit down and kind of share, a bunch of good tips, super interesting things, how you work for enterprise, your Caveman compression technique. It's really valuable, and that's one of the best things about the software engineering community. Is the collaboration, all the open source stuff. So thank you so much for that. Really appreciate it. Great talk.
Yeah, thank you.
Yeah.
Thank you.
Thank you.